Hey everyone, it's Professor Lamb, and we are going to go through the recursive exercises for Module 5 in this CodeAlong, and we'll open up recursive methods here. So we have 5 methods that we have to implement, but we can't use for loops or while loops. We have to use recursion. We're not supposed to use math functions. So for each method, we usually just try to figure out what is the base case. What is the smallest input in which we know the answer in advance? And then for everything else, we use recursion to break the problem down into that simplest form, until it reaches that simplest form, I should say. So you could find this in the readings, I think in the lecture notes for this week. Factorial is one of the easier methods to write with recursion. So what's the base case? The base case is if the integer input is 0, we know it should return 1. And if the second smallest base case will be 1, 2, because 1 times 1 is 1. So we don't actually have to write a second if statement. We can just write the case that handles it if it's 0. And that will prevent us from, multiplying it by 0 and zeroing everything out. So we'll do if n equals 0, return 1. That's the base case. Otherwise, we're going to multiply n, by the recursive call. So we're going to call the method within itself, reduce the input size by subtracting 1 from n. Let's see if that works. Yep. So that is how you do factorial in recursion. And you can see why recursion is really appealing sometimes, because it can be very simple code. And, at first it can be a little hard to wrap your mind around, but once you get the hang of it, there are certainly use cases in which it's the quickest solution. Let's move on to some digits. So for some digits, we need to identify the base case. The base case would be when there's only one digit left. So if we divided 10 by 10, we know it's equal to 1. Or basically, every time we divide by 10, we're chopping off a right digit until we're left with just a single digit here. So that's going to be our base case. Our base case is going to be if the input is less than 10, because then it's only one digit long. In that case, we just need to return the digit. Otherwise, we need to do modulus. So we would do n modulus 10. This will get the rightmost digit before we divide by 10. So we'll do the recursive call. And we need to divide by 10. So there's no test for this in the main method, but you could definitely write some if you wanted to, but I'm just going to run the unit tests and see if we got that right. Okay, so it looks like that did pass, and factorial is passed. So we'll move on to the next method. This is going to be the all-star method. So given any string, we need to insert these star characters between each letter. So what would be the simplest input that we know what the return value is? I think it would be based on the length of the string. So if the string length is I think we could do less than or equal to 1. We'll just return. We're not going to need to add any stars, so we can just return it as it is. Otherwise, let's get the first character at int 0. And we can add, here we can insert the star and then do the recursive call. And we need to make the string smaller somehow. So since we're starting at the beginning, we want a substring that starts at index 1, so we can just use the substring method for that. And this first signature, all it needs is the beginning index, so let's use that and set it to 1. Run our tests, and that passes. Okay, and finally we have this product of array method, and we know the recursive call is going to use this copy function that makes a smaller array. So let's see. The smallest array that we want would be of size 1. And in that situation, we would just return the only element because it's an array of size 1. Otherwise, we're going to start the operation by getting the first element and timesing it by the recursive call. And here is where we can just copy and paste this function. And we'll see if that works. Looks like I forgot something. Oh yeah, that might be off. But yeah, I think I think I need a calculator to double check this. So I'll fix this this is before I've uploaded the assignment, but I think that number's probably going to be off by a 0. Yeah, so there should be a lot more zeros. I'm just going to take that out. Actually, why don't we reduce it? So this would be 24 with 4 zeros. All right, so this is the unit test you'll have from the start. But that completes our Module 5 homework. Thanks, everyone.